In topic 6.2, we're going to be looking at solving equations with variables that are on both sides of the equation. So in this lesson, we're going to be focusing on two key concepts, looking at combining like terms as well as collecting like terms. So they're very similar, however, there is some difference between the two. Combining like terms means grouping the like terms that are all on one side of the equation. When we look at this one, we have 5x plus 4x minus 3 equals 6 as the example. You'll notice that the variables are already both on one side of the equation. So in this equation, we would go ahead and merge those two, calculating the mathematical operation, which was addition, which would give us the 9x. So when we're combining like terms, we're referring to combining the like terms that are on the same side of the equation. On the other hand, when we look at collecting like terms means that we're looking at collecting them on one side or the other. So in this example that's given here and in this topic, you're going to see that you have equations with variables that are on both sides of the equal sign in an equation. So in this case, collecting means that we're trying to gather the like terms and bringing them to the same side of the equation. So the difference between combining like terms and collecting is that collecting is gathering all the like terms and making sure they're going to the same side on the equation, whereas combining like terms is conducting that mathematical operation that exists between the two on one side of the equation. So when we're solving equations with variables that exist on both sides of the equation, it's really important that we organize our steps by picking your side. So typically on one side of the equal symbol, you'll have your variable terms, and on the other side of your equation, you will have your constant terms. So when we're building or calculating and solving these equations, it's really important that we isolate all the variables onto one side of the equation and then collect all those constant terms on the opposite side of the equation. So in this question here, we've got 7x is equal to 4x plus 15. Well, no, you can see that you have variables on either side of the equation. So in this case, we would need to be focusing on collecting the like terms. So the first step is we need to make sure we're picking our side. So picking our side, we're going to have the left side of the equation as variable terms and the right side of the equation as the constant terms. So right now we already see that we have variable terms on each side of the equation. So we're going to need to conduct some mathematical operations and balance it out and get our 4x onto the left side with the 7x. Now, typically you could select either side that you want, but you'll notice that in this question here, 7x is greater than 4x. So it is naturally easier to subtract the 4x from the right side and from the left side because we would still end up with a positive term. 7 minus 4 is still positive, whereas if we were to conversely subtract 7 from either side, we would end up with a negative. So just for simplicity's sake, it is easier to gather all the variables onto the side with the greater number of coefficient. So we're going to look at collecting the like terms, and in order to do this, we need to subtract the 4x from both sides of the equation. Very important that we're looking at both sides of the equation because what we do to one side of the equation, we have to conduct on the opposite side of the equation. So we have subtraction, which is the inverse operation of an addition. So right now we have a positive 4x, and in order to cancel this 4x out and get it zero pair, we would need to subtract 4x. So once we subtract the 4x, we would be left with that zero pair. So we'll go ahead and calculate by subtracting the 4x from both sides of the equation. And we would end up with 3x on the left side because 7x minus 4x leaves us with 3x. And now we are left with just the constant term on the right side. So now we have to go one step further because our variable is still not isolated. Our variable has a coefficient with it and we want to get it just by itself. So from here, we're going to need to isolate x by dividing both sides by 3. And we divide both sides by 3 because 3x is the same thing as saying 3 multiplied by the variable x. So that inverse operation of a multiplication is a division. So we're going to have to go through and divide 3 out from both sides. So 3x divided by 3, we end up canceling those 3's out, leaving us with just the x, which is what we're looking for because we want to isolate that x on the variable side. And then on the right side, we have 15 divided by 3, which leaves us with 5. So now you're going to take a moment and pause this video to try it on your own. Try calculating and solving the equation 5x minus 2 is equal to 3x plus 4. Once you have solved this equation on your own, we're going to walk through this equation together. So the first step that we're looking at is we need to make sure that we're splitting our equation into our two sections. So we've got the variable terms on the left side and the constant terms on the right side. So to get started, we want to make sure that we're collecting all of the like terms. So the first step is going to be to get all the variable terms onto the left side of the equation. And in order to do so, we need to cancel out the variable terms from the right side. So we're going to subtract 3x away from both sides of the equation, which will leave us with that zero pair between 3x and negative 3x, canceling out the variable and leaving us with 2x minus 2 on the left side and a simple constant term of 4 on the right side. The next step is to then figure out what the inverse operation is for the constant term on the left side. So right now we have a subtraction, so that's why we're going to have to add 2. Because we want to get that zero pair, we need to cancel out the 2 on the left side. So we're going to go ahead and add 2 on both sides, cancel out the negative 2 by finding its zero pair, and we are now left with 2x is equal to 2. So right now we have 2 times x is equal to 2, and we have one more step to complete before we can isolate the x variable. So we have a multiplication between the 2 and the x, so we're going to need to conduct the inverse operation, which is division. So we're going to go ahead and divide both sides of the equation by 2, which will leave us with x is equal to 1. So remember that our final answer, we're always looking to have that isolated variable by itself. For number 3, you're going to again take a moment, pause the video, and try this question here and solve it. Once you have found the solution to this equation, you can then click through or continue watching through the video for the solution. So first step in this equation here is splitting up the like terms. So again, we're going to group all the variable terms onto the left side of the equation and all of the constant terms onto the right side of the equation. You're going to notice that this equation actually had an extra step in its solution. So the first step in this solution is to ensure that we're actually combining the like terms. So you'll notice that on both sides of the equation, we can actually combine before we start collecting the like terms. So on the left side of the equation, you'll see that we have 2 terms that consist of a variable, and on the right side, we have 2 constant terms. So we're going to go ahead and combine those terms before we move forward. So 6y minus 3y leaves us with 3y, and 17 minus 5 leaves us with 12. So we're going to go ahead and combine those terms, leaving us with the ones that are in the circle. The next step is to now collect the like terms. So the first one we're going to do is we're going to get rid of the variables on the right side of the equation, and we're going to subtract y from both sides. Now we have all of the variable terms on the left side of the equation, but we still have a constant term on the left side. So we're going to go ahead and calculate the inverse operation of plus 4, which would be subtracting 4, on both sides of the equation. 4 minus 4 would leave us with 0, and 12 minus 4 would leave us with 8. So now we have one more step to complete before we can finish isolating the variable y, and that is to divide both sides by 2 because we have a multiplication between the variable and the coefficient 2 on the left side. So we need to get rid of that coefficient 2. So we're going to go ahead and divide both sides by 2, leaving us with y is equal to